All right, everyone, as a part of the continuing Meet the Scientist series that I alluded to on one of my last uploads, I wanted to give you a chance to meet two DOE-funded university researchers. On the right, we have Rick Colwell from Oregon State University, and on the left, Laura Lapham from the University of Maryland. They're going to talk to you a little bit about their work at the site, their historical work, and get you kind of the details into their unique sampling device. Rick?
Okay, thanks, Ken. So our project has to do with examining the water chemistry and the microbiology of these systems, aquifer and the river system here at RMBL at the DOE site, related to what happens during the winter. So it's access during the winter is hard. You can see we're already sort of at the edge, I think, but we're going to deploy this osmo sampler system that Laura's holding down in this well, which will collect the water chemistry continuously through the course of the winter while we're here, and we'll probably refresh it at some point next year. But the basic idea is that when it's difficult to get in here to sample, this sampler will be autonomously collecting these samples so that we can more effectively put together the biogeochemistry of this system through the course of the whole year and work with, I think, the computational modelers doing it. And I just say that for me it's very exciting because I first started working in this part of Colorado in 1994, supported by the Department of Energy to do early subsurface science program work, and I'm really excited to be back.
Great, thanks, Rick. So, Laura, before you give us kind of a description of what underlies the Osmo sampler, we should also mention that we'll be deploying some similar samplers down in the East River itself to collect continuous overwinter measurements of stream water samples. Right now, however, we're doing our first deployment in what we refer to as the Shumway well. You saw that earlier. So, Laura, why don't you describe to us the Osmo sampler?
Okay, so the heart of what we're going to deploy here is called an osmo sampler. And the way it works, it's this top part of this very sophisticated package here. And the way it works is by osmosis. So there's a chamber with saturated salt. You can almost kind of see the white, pure sodium chloride in there. There's a semi-permeable membrane with which the water below diffuses across. And that diffusion creates a pump. And so essentially we're just deploying a pump. Now the nice thing about these is that there's no power needed. And so they just work. We connect that pump then to a very long coil, which you can't see, of copper tubing, very small outer diameter, 16th inch tubing that is pre-charged with water, and essentially the sample is going to be collected through that tubing continuously throughout the winter. And so when we recover it, we can go back and cut this coil into sections, and essentially as a time stamp. And so this way we can get maybe 5 or 6 day resolution throughout the wintertime when it's very difficult to sample.
So one thing to mention is that that coiled tubing, basically you know the water temperature because we'll have a temperature logger in the well, and so from that you can calculate the flow rate at a given temperature. And so with that flow rate, you know essentially how much water has moved down this continuous coiled tubing as a function of time. And then, as Laura mentions, when you remove it from the well, knowing that flow rate, you can cut a specific length that corresponds to a given volume, with that volume then being, as Laura notes, a time-weighted average over some number of days, 3 days, 5 days, 7 days. So thank you both very much. We look forward to seeing these results once we get into the summer conditions. Certainly doesn't look like summer here today.
No.